All right, welcome back. We're getting into resources with this one. So in this episode, we're going to create the integration tests for how we're planning on at least doing the first part of CRUDing our resources. So to begin there, we have our test folder that we created last time. We're going to create a new file in here, and I'm just going to call this resources. And we're going to have a bunch of tests in here all about how we're going to interact and manipulate resources in the world. Now you'll notice I don't have anything in the main library besides that one test that they gave us at the beginning, which we don't actually need. We'll probably get rid of that later. Instead, we're going to sort of code pretending that this exists, which will help us in actually writing it to be, to work the way we want it to work. So that way we don't code a bunch of stuff and then realize that we want to use it in a different way later. So to begin with, we're going to have the create and then get immutably, because that's an important part. So let's go ahead and write that test now. So we'll have our function. This is going to be create and get resource immutably. So we need to get like the world out of here. So remember, we don't have this yet, but that's okay. So we're going to have our let. Now we're going to have the world be mutable for this. And I like to always create my libraries or like any structures with like a new keyword. It might be just because I'm used to like other languages that have like, the ability to just do like new on the class name. But I do like this a lot, especially if I wanted to like set up what the defaults are. And I don't necessarily know what's going to be in here. Okay, so we're going to create a world. Now we're going to have to create a resource also to store in this. My thoughts on this is we can have we can use the any trait, and we're going to create the resources as like structs that then we can just store in here. And so each resource will get its own struct to hold it. So we can have a struct. What's a good resource for this? Maybe like a current frames per second would be a resource that's not tied to any one entity. So maybe like we'll just call this like FPS. You can even call this like FPS resource. And this is going to be a tuple struct that's going to hold a, let's do this as like a U32. And that's all this really is going to be. Now, what I have learned is that if I want to create these structures and they're not in the same file, and so therefore I need to like add them in, you need to make this a public entity here. So that way you can extract, add in and get out really easily. Okay, so I want to then add a resource in. So world.resource, and then I want to just give it this resource. So FPS resource, and let's give it, we're aiming for 60 frames per second usually. So we're at 60. So that's kind of what I want to have happen for adding a resource in. Now getting it out could be interesting because I didn't actually give it like a name or anything else, but there's only one resource of this. So what I want to be able to do is let like our FPS equals world.get resource, and we're going to have to tell it like a type. So I can't just say, hey, FPS resource here. That's not going to work if I just say like, hey, give me the type that's this type. What I can do is use the turbofish syntax, and we're going to say FPS resource here. And there we go. Okay, so this is going to be that. Now, as I'm thinking about it, what if I'm wrong? What if I didn't actually add the resource in? I probably need this to be an option coming out. So this should probably be a sum. So we really want this to be like an if-let. So an option here. And then that way, okay, so then if I try to get a resource that doesn't exist, we'll get this. Okay, so FPS comes out here. And then we probably just, at this point, we could just test the assertions to make sure that it works just fine. We'll do a assert equal. We'll look at FPS, and that we should be able to just compare with our like a new FPS resource here. Now, if I want to extract the data, I would have to do like .0, and then you should be just 60 then, like that. Now, I could get away with just dereferencing this if I, just do FPS. If I wanted to do that, what we could do is impl deref for FPS resource. Impl deref. Are you upset because these things don't exist? Well, let me comment that out and maybe this will be happier. Impl deref. No, you won't tell me. Fine. I think it's standard ops deref for FPS resource. You can't find that. Let's go look at the documentation for deref really quickly. So that's up here. We're gonna look at deref. Yeah, it is standard ops deref, and then we can see that this is what it's looking. So we're gonna have this type target and then a pub function deref. So I can actually copy you. And inside here, we don't need this must use. We're gonna have a type target is gonna be equal to a U32. So that's what we're gonna deref into. And we're gonna have, this doesn't need to be a public function because just it's a trait. It knows it has to be public. For deref, we're gonna then go to self-target. So here we're going to just basically say a self reference to self.0. So grab out this U32. Notice here that it's actually going to return a reference to what this U32 is. So that's going to be interesting, because that means when I do this, this is still a reference at this point. I would have to do a double dereference to get that out, which is it's not the nicest interface. We could like implement like a get function, which then it auto dereferences if we do like a dot. But that's not necessarily what I want. I could compare with, this, but I don't know if I like feel that that's any better or not. We can try running this now. The problem we're going to run into is that world doesn't exist. So if I, none of this code will actually work until we actually create our world and get everything passing for this. So let's jump into it and get this working. Okay, so we're going to create a world new. So in our main library, we want to, up here, we're gonna have a pub struct world. we're gonna hold things in it like the resources in here eventually. Now we also know that we need like a new let's go ahead and remove this test. That doesn't need to be in here. And we can import world now. Can we? Oh no, we have to restart Rust Analyzer, I bet. I have found that Rust Analyzer does need to be restarted several times, usually during a project, especially after you're like creating new files, or just every once in a while it needs to be restarted. Okay, so now I can import. So that brings in world. Now it's yelling at me that I don't have this new method. So I don't necessarily have anything to like test for this yet. Except maybe I can have like a default version of world, and then I can compare that as a test. I don't know how useful that's gonna be. But a pattern that I like to do is derive default for this. And then I can do impl world. And we're going to do a pub function new, and we're going to return a self. Now this self is with a capital S. That's going to return this type right here. So whatever that I impl, self references that type. And then I'm going to do self : default. So that way new returns the same thing that a default does. Now, what I can do is like I can create a unit test that tests this to make sure that like new always returns a self. I would then have to do a partial equal on this, and I'm not completely sure that partial equal for everything that we're going to put into this is going to work, especially as we like start adding in like the any types and some dynamic dispatch. Okay, so coming back to here, new works, as we can see. Next up, we need to make sure that we have this add resource. So I noticed that we have like the world needs to add the resource. Even though we're gonna have a resources struct that's forwarding on this, we're gonna have to add this here. So a function add resource. Now in this case, we're going to need you to be mutable with the self, so that way we're going to mutate self here. And then looks like we're going to just take in the resource. Now we're going to use dynamic dispatch for this. So it's probably going to implement any for that. So we're going to say whatever this is going to be our resource data. So we'll just call this our resource data. And it's going to impl anything. So we're going to use the any trait here. And then at that point, now this is not going to return anything. It's going to stuff it into inside. Now, I'm not necessarily doing anything here, so this function is empty. It's going to yell at me that I'm not actually using this this variable, but that's not really a problem. Okay, so this is no longer upset at us. Now, continuing down here, we have get resource, which is supposed to return back what this resource is. So that's going to be the first one that we can't necessarily do very easily on the world here. So we need to actually start creating the what is it going to be, the resource struct, and then work on it there. So let's go do that. I am going to create a resource.rs. File here. In the main library, we're going to do a pub mod resource. I'm actually not completely sure this needs to be public. Let me make it not public. So by using mod, we're telling Rust, hey, look for this file named this with the .rs afterwards. Now it's also going to look for a folder if it can't find this with like a mod inside of that. But because it's going to find this, everything's going to be fine. And now we're going to need to actually add this resource in here. So let's go into resource. I'm going to do a pub struct resource. And we know we're going to have to store our resources in here somehow. What we can probably do is set up our testing and do the inner loop testing for this. So the outer loop is just the full sort of like CRUD test where we're adding a resource and getting a resource. So let's do an inner test for adding a resource. So this is, I'm gonna do a test. I have a, in VS Code here, just added, it's not really a macro, it's a snippet to create like a little test section for myself. Okay, so that brings in super, so I have access to a resource here. Let's add in a test, and then this entire test, we're going to name it add resource. Don't necessarily need to return anything from the test here, although it is possible to return results from tests now. Okay, so what do we want to do? We want to be able to create a new resource. So that resource, we know this is going to have to be mutable. And I'm going to want to be able to do this. Well, now I can't actually do that, so let's implement that really quickly. We also know that this is going to have to implement default because a resource is going to have to be held by our parent. So this actually must, like the world. So we're going to have to derive default. So in this case, we could do self default here. And so that gives us a new resource. Okay, so we have this. Now we want to be able to add in a resource. Let's actually create a example resource very similar to that FPS that we have in here. So what's another one? Maybe we can have like the width of the entire world. So we can have struct world width, and that's going to be maybe like an F32. So let's create this resource here. So world width, it's going to be a world width with, let's just say 100.0. Then we want to add this resource in. So what I'm thinking of doing is we're going to just do resource dot add, and then we're going to have this world width passed in here. Now, add doesn't exist, and also we don't like have any place to like put it yet, but we'll get to that. So we're going to have a hub function add. We know that this is going to have to be mute self, and then we need this like impl any again. So impl any. Okay, import any. Oh, you know what? I forgot the name of this. This is going to be the actual like resource. Let's just have this called data. And we're not going to return anything at all. So far, this is happy. We have our resource add, and then we want to probably like check inside, like reach inside of resource to make sure that like it exists in what we're looking for. So we're going to be having a hash map where the key is going to be the type ID of the resource, and then the value is going to be, well, the value of the resource. It's not going to be quite as simple as just the resource itself because it is dynamic dispatch. We're going to have to box that up. But let's make sure that we can now like extract this out. And I'm going to go directly into resource from this test to get this out. Now it doesn't exist yet, but we're gonna get to that in a second. So we're gonna have a hash map. Hash maps, we can use get, the get method, which will give us an option of the thing back. So let's do a, and we can unwrap, which, because if this test fails, that's, we want it to fail. We want it to let us know that things are not super good. So let's do a, this is gonna be our resource back. So read, let's see, stored resource equal to be, we're gonna do, so our resource, and I'm thinking this should probably be named resources because it's holding more than one of them. So we're gonna do resources, and then we're gonna have like all the data in here, all the individual resources. So I'm gonna call this data. And then we're gonna have a get method. Now I'm not getting any of the fun sort of like helpers here because it doesn't actually know what this is. Okay, so get, we're gonna pass in a reference to our type ID. So let's just go ahead and create our world width type ID. It's gonna be world width that type ID. As this is going to be a reference to the world width type ID. Now, I'm just going to unwrap this. So that way we can know, hey, if it's, if you couldn't find it, just go ahead and crash on me. That's fine. I wanted to that to happen in the test. Okay, so let's make sure that this is running because you're going to be very unhappy that we don't know what data is. Data is going to have to be public, so that way, well, is it? I don't think so because we're going to have methods to access this. Let's see whether or not in our tests, having this not be public is going to cause us to have problems. We're going to have a data field here, and we know this is going to be a hash map. Now our key is going to be a type ID, and our value is going to be something that implements any, but I can't really just do dyn any here, even if I really want to, because it's going to say, hey, we don't know what this is. We don't know what the size is going to be at compilation time. But in Rust, if we want to just basically take something that we don't know what the size is going to be and kind of know what the size is, we can box it up. So we're going to use a box, and then in this, it's going to be dyn any. And this is fine because the box, the size, we know the box's size at compile time because box is storing what it has in the heap memory. So what's happening behind the scenes is box is basically just a pointer towards a location in memory and like how much size is going to be in there behind the scenes. So box is very small. Box also implements deref automatically. So basically we just access the stuff inside of it as if the box isn't really there at all, which is really nice. Okay, so we have you, and then slowly over time, this is working now. We can see that our stored resource, we now have this box dyn any. Okay, perfect. Now, in order to like make sure that what I got out of it is correct, we have to do a, we have to extract out our thing. Now, to get something back from any, we have to downcast it. So the way that looks like is, our downcasted, this is going to be our sort of like extracted world width. It's going to be our stored resource. I'm going to downcast this. Now we can downcast ref. And I have to tell you what type you're going to be. So you're going to be this world width. And it's going to give me this option. So once again, if you're going to fail, I want to know. So I'm going to unwrap here so it crashes on me. Now I have a reference to a world width. I should now be able to compare these to each other. So let's do an assert equal. I want world width dot 0. I want you to be equal to extracted world width dot 0. You should be the same. Although in this case, I lose this because I give ownership to you. So what I'm going to do is actually just say you should be 100.0 directly. Let's see, borrow to move value. World width has type. Oh, extracted world width. I removed the wrong one. And then you should, yeah, strict comparison. So if you ever want to actually like compare two F32s together, even though it's just .0. So in this case, it should be fine. If it was sort of like randomly set up there, that could be a problem if it was like an unknown number of decimal points. However, in this case, it's fine. So I'm going to, at the beginning of this function, just basically tell Clippy, hey, this is okay. Everything's fine. So it's going to be hash, our brackets, and then allow. And then we're going to do Clippy, what is it? Floats. Float compare. And then that makes that error go away. So we have no errors in here anymore. And if I run these tests, but it's going to fail. What's failing about it? Oh, we called unwrap on a none value. Well, that makes a lot of sense, doesn't it? Because we're trying to get this out and we have this unwrap here, but we never actually stored it inside of this this data. So let's actually fill out this function so that way the tests pass. So if we have this data, it impulse any. We can get the type ID off of this, and then we'll get our hash map. Let's see. Can I get a type ID off of just data that impulse any? Let's try this. If I do data.type ID, oh, that actually works just fine. So let's do that our type ID is equal to data.type ID. And then we want to insert into here. So we're going to do self.data.insert. Our key is going to be this type ID, and then the value is going to be the data, but it can't just be the data. Remember, we have to box it up. So it's going to be a new box, and inside of the box, we're going to put this data, and that's going to be fine. Now, this insert function does return an option for us. The option is basically, hey, if it had something in it previously, here's what that was. Well, in our ECS resource, we don't care. If we just overwrote the resource, it's gone forever. So here is adding that. Let's now run our test and see whether or not everything is good. And it is. We actually see that this inner loop test is now working. We're able to store our data into that hash map just fine. Now, if we come back to these outside resource tests, if we run this, we still get a problem here because it's saying, hey, we can't get the resource out. We expect in this sort of like integration to also get the resource. So let's go ahead and do that as well. So here we have a get resource. Okay, so getting the resource means that in this case, we notice that we're going to pass in the type here. And that means we're going to extract out just a reference to it. And also it looks like we're going to get an option for that. That actually is going to be very simple here. Let's create another function for getting a resource. So function get resource. And now we're gonna test like actually getting the resource. Now we do have to like insert a resource for this, which is kind of duplicating this test here. I'm gonna be okay with duplicating this code for right this second, but we're gonna clean this up afterwards to not be so duplicative if possible. Okay, so resources.add. We have our world width. Okay, so that's great. Now, I don't want to reach in and get this way. I want to now extract this data out using like an actual method that we really care about. So we want this to be an option. So if let sum, and then this is going to be our extracted world width equals, this is going to be our resources. So we had add, so let's just like have this be like a get ref. I get ref. Now we need to give it the type here. So we're going to give it our type, which is this world width. World width. Okay. And I don't know if I need anything else out of here. So that should get us our extracted world width, and then we should be able to do our same compare that we did before. So assert equal. I'm gonna move our allow Clippy up there at the end, so that way all of our tests should allow float compares. Let's do, we want our extracted world width .0. I want that to be equal to this 100.0. So that should work for this. Now you're gonna yell at me because we have this, we don't have a get ref. Let's go ahead and create it. Ref, now I don't need mutable self because we're only getting like a reference to self. So I just need a reference to self. Now I need this type, but we're not passing it in here. We notice we're doing this turbofish syntax. So to take that in, we're going to take in a type here. We also know that we're going to return an option. And inside the option, we're going to return probably this box dine any, because we noticed that we're going to be, well, is that true? Is that how we want it to be? We can clearly see I don't need to downcast at this point. So I actually want to be able to just, grab this out here. I want that ref. Can I do that here? So I want to have a reference to the data, to like this T essentially. Because we do know this type, yes. Okay, so let's go ahead and see if we can get this working. We're going to get the ref out of here. So now if I want the type ID of this, it's a slightly different method than we used here because this is only off of like actually discrete, things. There is a type ID struct. So we can do type ID, type ID is equal to type ID of, and then we turbofish syntax this T in here, and that gets us the type ID. Okay, so it's just the LNS that we haven't returned anything yet, but that's fine. So next we need to extract out. So we're going to do an if let sum of like whatever our data is equals self.data.get and a reference to this type ID. Oh, VS Code, thank you for trying to help. Okay, so now we can see that we have this box dyne any. So now we should be able to downcast this, and then we're gonna return that, which means that we know that if we can't find this at all, we're returning a none. So we can just do an else, and we're gonna return a none here. So in here, let's try to downcast, and let's see if we can just return the result of downcast ref for this. So we're gonna do a data.downcast ref. We also have to tell it what this type is. Now, do I really need to give it this? Can it figure it out? Well, it's yelling at me about something else now. So it's saying like, hey, T is like too broad. It could be too many different things. So let's go ahead and restrict T down to just a couple things that we know we absolutely have to have. Well, we know that T must implement any. But our other problem is, well, actually, let's see down here. Strict comparison. Then let's go ahead and move this Clippy out above our mod here. That way everything is now following that. And we're good to go now. So let's go ahead and run this get resource test. Oh, I forgot, for every test, you have to have a test here. Now I can run that. And it passes. Perfect. So that means I'm able to extract it out, and it looks really nice. It's much better. We don't have to do that downcast ourselves. Okay, and all we have to do is like pass in this type like that. So perfect. Now if we come back to our resources here, we want this get resource. This is still failing here because we don't have a get resource on the world. So let's go ahead and change that. So world get resource, we're gonna come into our main library and we're gonna add in, well, we have get resource here. You're just yelling at us because get resource isn't returning the right, oh, that's add resource. We need get resource. Okay, let's do it. So pub function get resource. This can be just a reference to self, and then nothing in there. And we know we're going to return an option with a reference to like whatever data is looking for. So it's going to be this T. And then you're going to take in this T here. And we know the T has to implement any. Okay, and so then in this option, we also know we're just gonna reach out into the, see, are you gonna make you happy? No, because we have to return like whatever this is. So let's just reach into our resources, which we don't actually have in here. So let's go ahead and set up resources. So resources is gonna be a resource. We have the default setup here, so everything should still be good. Then we're gonna do a self dot resources get ref, and we're gonna pass in this T. And then we're gonna return the result of that. So that makes you happy. Perfect. So back to here. In resources, we can get the resources out and assert equal. now we have, let's see. FPS resource doesn't implement debug. Okay, we need debug in order to, okay, so let's derive that on here. We also need to derive, oh, partial equal. Oh, because of this reference. Otherwise, we can just do, we can just grab it out like this, and that'll also solve that. Okay, so if we run all these tests, they show us passing here, and is that correct? Okay, so we have the world mute. Okay, so we should be able to add a resource, and then we're trying to get this resource back, and then the FPS that we're getting back is correct. For add resource, I noticed that this actually isn't doing anything. So did I really add a resource here? We add you in, and then world get resource. Okay, so then why do you pass? Test screen, get resource immediately, test result, okay, passed. I would imagine that this should not pass for this. Oh, wait. This is my integration test. So I would think that this should not pass for us. Mostly because add resource doesn't do anything. It's not like actually adding that resource in. I'm not like accidentally going too far in here, right? We're doing add resource. Yeah, that should be fine. Let's try just running the test manually here. Cargo test. Yeah, this is also showing just fine as well. Something that we can do to like just double check ourselves and like make sure things are working the way we expect them to. We have a debug here. Let's try debugging the world at this point. So we're gonna do a debug macro on the world. Now, if we try to run a debug just out here, you're not gonna get that out. Also, world needs to implement debug. Okay, we can derive that. Debug. Now resource needs to derive debug. And world borrowed. Oh yeah, I don't want to actually debug, but take ownership of that. Okay, so the way that I can get access to this is not through just like normal cargo test. There is a way to sort of like tell it, hey, print out all of those debug variables. But what I can do is run the test in here, and then I'll see the debug come out. So yeah, we see there's absolutely no data in here. So what's going on? Why are we not seeing that? And why are you succeeding? Well, do you know why this is succeeding? Because if let sum, it's a none that comes out of here. So this test isn't actually happening, because imagine, like, look at this. If I switch you to like 65 and I run this test, it still passes. So what we want to do here is panic. Panic, which is should not be a none. We can actually assert that this is not a none, I think. Let's do an unwrap on this. So that way we can just do, okay, so let instead of an if let, we'll do a let FPS equals this dot unwrap. That should now be this FPS resource. And then we can assert that okay, so I like this a little bit more. When we run this, now we get our failure. So our failure is showing that, hey, we panicked on an unwrap call on a none value because the thing wasn't actually in there, because we need to implement this here. So let's go ahead and do that. We're gonna do a self.resources.add, and this is gonna be the resource data. Okay, let's try this again. Now we see, here's our data in here, so that's fine. Our failure was left is right. Oh, hey, our 65, because we, as part of our test. So we put a 60 back in there again, run our tests, and everything is happy. Okay, let's go ahead and clean this up now. So we have debug, we don't need that anymore. If we run all of our tests, we shouldn't get any problems. So everything is fine here. Then let's clean up all of our warnings. So here we have this new. So associated function is never used, new. Okay, so this is letting us know, hey, we don't need this new function here, because we have the default on and world is just creating this from default and it's never like creating it. So I don't actually need that new. Now this is going to cause our test to fail here, but let's create this the exact way that the world is going to create it, with a new. So with default. Okay. Then down here, also need to change you to default. Okay. Unused variable world with type ID. So yes, we are definitely not using you because the type ID is being used elsewhere. So we just don't need that line. All right. And then the final thing here, for this unit test, we have very similar things happening here. For like adding resources, we create a resource and we're adding it into the world. So I'm going to create a helper function in here to sort of do that for us. So I'm going to call this a function. I'm not going to put the test on it, so therefore it's not going to run it when I do cargo test. This is just going to be something available, available to us. So this is going to be insert data. I'm not going to need to take anything in. I'm not going to return anything. Is that true? No, we're going to have to create the resources. Let's actually have it return a resources. So a resource. Let's call this like initialize resource. And inside of here, we're going to do this. We're going to create a resources. We're going to create a world with, and we're going to add this in. So copy you, paste you inside of here, and then we're going to return resources. Oh yeah, and we don't need this entire world with type ID. So then you can be replaced with just a call to initialize resource. We can do let resources equals that. Then the rest of it, now this world type ID, we need to actually figure out what this specific type ID is that's going to be in here. Now we know it's this world width here. So we actually can do this command to get that type ID. So type ID of world width, like that. And that's going to give us the type ID. Let's do the same thing here. So resources equals initialize resource. And our get ref, well, that's the world ID, so that should be fine now. All right, let's go ahead and make sure everything is still working. We're gonna do a full test, run all the tests. And that is all the tests are passing. So that's great. We have the first part of CRUD working with resources. So we can create and read. Now we can't update yet. That would require us to have like a read mute, but that will be coming in the next video. So stay tuned and I'll see you there. Bye.